You're making families wrong. That's right. It's 2023, and if you're still using massive, clumsy type catalogs, then you're doing it all wrong. Fortunately, in about 5 minutes, I will show you how Revit formulas and data validation can change your life and how you make families. There's a few reasons we've done away with type catalogs. One long list of product codes and sizes are frankly not helpful and slow you down during the design development with having to keep track and manage an extensive list of options. Everyone's had to deal with Revit's issues when a similarly named or conflicting type is loaded in. Good luck getting that sorted out quickly. And 3, general Revit weirdness can often get in the way of what is supposed to be a straightforward process of just picking a size. That's why we use Revit formulas to build data validation systems within our families that make it possible for users to type in what they want. If that sounds like a lot of words, I promise you it's simpler than it sounds. We'll cover 3 ways you can use Revit parameters and formulas to build more robust families that are easier to use. Let's dive in. Our first technique is all about yes, no, or checkbox parameters, and how we can use them as radio buttons. For those who don't know, a radio button is an icon representing one of a set of options where only one can be selected at any time. They are mutually exclusive. To demonstrate this, I have a simple cube family here with the width, depth, and height all set to a parameter labeled length. Let's imagine that this cube is made by a manufacturer and is only available in sizes 24 inches and 48 inches cubed. Rather than making 2 types, I'm going to open my type editor and create a yes-no parameter in the dimensions category. This parameter we'll call modify 24-inch length. Next, I'll make another yes-no parameter in the dimensions category and call it modify 48 inches length. As they are now, these 2 buttons are independent from each other. I can select both or neither, which is not how radio buttons work. To link these 2 together, I'm going to write a short formula into the formula box for modify 48-inch length. That formula is not, parentheses, modify 24-inch length, end parentheses. Now, modify 48-inch length will only be activated when modify 24-inch length is checked off. So how do I connect these buttons to my length parameter? Well, first I'll start by renaming our length parameter to actual length, so we clearly communicate that the length parameter is what's actually changing here. Next, we need another short formula that takes our radio buttons as input and outputs a specific length. That formula is written like this. If, open parentheses, modify 48-inch length, comma, 48 inches, comma, 24 inches. Essentially here we're saying that if this condition, modify 48-inch length box, is true, then the length is 48. Otherwise, or our false statement, it's 24. Paste that back into the formula box for actual length and give your radio buttons a try. The cube should flex between 24 and 48 inches at the touch of a button. That was a pretty simple way to have a parametric family flex quickly between 2 options without using types. Let's look at what a more complex system could look like. The next system I will demonstrate is an integer spinner. I use these frequently when I want a user to select from a list of options. It may seem odd to use an integer parameter for this, but it's impossible to create more than 2 radio buttons in Revit, and Revit does not allow for simple drop-down menus for selection. Back with our sample cube family, you'll notice a few different visibility options are all on at once right now. Essentially, I will make an integer parameter and tie each integer to another visibility option to allow the users to select the side of the cube they want the pip on. Let's start by creating an integer parameter in the construction category called enter pip side number. Note that I'm using an instance parameter again. Before I close out of the window though, I'm going to add a tooltip. Let's first direct the user on how to use the parameter. We'll say enter an integer to designate the pip configuration of this unit. Next, let's outline each option. 0 equals none, 1 equals front, 2 equals right, and so on. If I want, I could make a validation parameter at this point, actual pip side number, but I can make this work with just this one parameter. The last step is to tie our integer parameter to our visibility parameters in the visibility category. These yes-no formulas will look a little different from the other formulas we've written because true-false parameters are inherently truthy. So we can leave off the if conditional and type in the true condition for each. For the front greble's first visibility option, The formula is enter pip side number equals 1. The rest of the visibility parameters continue in the same way. After writing a formula for each visibility parameter, we can cycle through the options with our integer spinner. Note that you must turn on preview visibility to see this work in the family editor. But what would happen if we had a whole range of lengths that we wanted users to select from? How would we allow a user to type in any length and use data validation to have the correct outcome? And that's how we get our last technique. By setting up a few parameters, we can write a simple formula that will clamp down the possible outcomes of user input. We'll start again in our sample cube family. Let's say this time the cube can be any size from 6 inches to 72 inches. First, instead of setting up yes/no parameters or an integer spinner, we're going to add a number of length parameters. The first two lengths I need are a minimum and a maximum length. Let's make two parameters in the constraints category, min length and max length. Leave them as type parameters and enter in our lengths. Min is 6 inches, max is 72. Now we need another length parameter, this time an instance parameter in the dimensions category called enter length. We'll leave the other length parameter as actual length for now. Now that we're set up, we can write our formula. I like to write these longer formulas in Notepad++ for legibility and also so I can save the formulas from a family in case I need to audit it later. Let's think of our formula in parts. I need to set the length minimum and the length maximum, and then I need to allow for all measures in between the two. Our formula should look like this. Notice how each line starts with a condition, then an outcome, and then our last line acts as an else if to be performed if neither of the above conditions are true. Be sure to end your formula with the appropriate number of parentheses if you don't want Revit to yell at you. After pasting the formula into the formula box for actual length, we can now type in any length into enter length, and the dimensions of our box adjust within the specified range. Entering a length too large or too small will automatically make actual length stop at its min or max value. And that formula will work in most cases, but what if you want to restrict a user to a certain increment within that range? What if our cuboid can range from 6 inches to 72 inches, but only be adjusted in 6-inch increments? Let's take a look at our last line, the else if. We can use some simple math here to force the validation to only accept lengths at our specified interval by adding a round modifier, and then dividing and multiplying the entered length by our desired increment, like so. Once again, be sure to end your formula with the correct number of parentheses. Paste this into actual length, and now we can see that any length entered into enter length automatically snaps to the nearest 6 inches. Revit formulas are a powerful way to make dynamic parametric families that can be altered at the push of a button. Instance-based families with well-thought-out formulas are often more intuitive to use and easier to manage than huge typed catalogs and endless duplication of types during the design development phase. Formulas can also make a family abide by the rules of a real-world product, such as minimum and maximum sizes. And if you found this video helpful, feel free to drop us a like or a comment, and don't forget to subscribe for more tutorials and Revit tips and tricks in the future. See you next time.